Okay, lesson 5, which is on page 43 of your book, is negative exponents and the law of exponents. So we have one more rule. It's the negative exponent rule, which says for any non-zero number x and for any positive integer n, we define x raised to the negative n as 1 over x to the n. So you can see that basically the reciprocal is true. Like you flip it, I guess you could say you flip it, and then the exponent is positive. So note that this definition of a negative exponent says x raised to the negative 1 is just a reciprocal, again, of 1 over x of x. As a consequence of this definition, for a non-negative x and all integers b, we get x raised to the negative b is equal to 1 over x to the b. So for exercise 1, you're verifying this statement by plugging in some values just to show that it's working. So if this is just kind of an explanation, you don't necessarily have to. I'm not going to go over it, but you can read that if you'd like and pause. So anyway, I'm replacing these. I'm substituting x equals 3 over here. So this becomes 3 raised to the negative b. B is negative 5, so it's negative 5, negative 5, since b is already negative, is equal to 1 over x, which is 3 raised to the negative 5. So this is what I'm looking at proving. So the right side, right here, is if we have the right side is this side. The right side is here, and you have 1 over 3 to the negative 5, and that is going to be equal to 1 over 3 to the 5, because I'm trying to make it positive. So really what that's saying is 1 divided by 1 over 3 to the 5th, and with division of fractions, it's the same thing as multiplying the reciprocal. So 1 times 3/5 over 1. So that's the same thing as that. And so 1 times 3/5 divided by 1 is just 3 to the 5th. Sorry, I said 3/5, but it's 3 to the 5th power. And that's just equal to 3 to the 5th power, all right? So, and then the left side, oh, I did both sides on the one, that's why that doesn't make sense. So the left side, this is just, sorry, I don't know why I wrote that, but it's just equal to 3 to the 5th power. You have a negative times a negative, which is a positive, right? So it's just 3 to the 5th power. So therefore 3 to the 5th equals 3 to the 5th. Both sides are equal. This proves that the negative exponent rule is a working rule. Okay, and then exercise 2 says what is the value of 3 times 10 to the negative 2nd power? So you're using this rule, and it's 3 times 1 over 10 squared, which is equal to 3 over 10 squared, which is equal to 3/100ths, which is equal to 3/100ths. Just writing it as a decimal. For exercise 3, same sort of deal there. You can look at that. You can pause the video. Just writing it as a decimal at the end. And then exercise 4, you're expanding it out. This is good practice for scientific notation, which is coming later. So you have 4 times 1, right, times 10 to the 0. If I want to have a power of 10 for every single digit in this number, so then 0.7, which is 7/10, will be 7 times 10 to the negative 1. So 7 times 10 to negative 1 would be, I'm moving the decimal backwards 1. And then 2 times 10 to the negative 2, because I'm moving the decimal backwards twice. See, it's in the hundredths place there. And then 8 times 10 to the negative 3. So I'm just multiplying it basically by a power of 10, a negative power of 10, which is making it 8 thousandths. All right, so for the exercises 5, 6, 7, 8, 9, and 10, and also you could continue on because this box on the next page is just reviewing your work. We could continue on throughout, lesson 5 classwork, and then the next video we'll go over the solutions pretty quickly. All right, thanks.